Greetings from Girl Hacker Club. 7th of April, 2017. Today, April 7, 2017, WikiLeaks releases Vault 7 Grasshopper, 27 documents from the CIA's Grasshopper framework, a platform used to build customized malware payloads for Microsoft Windows operating systems. Grasshopper is provided with a variety of modules that can be used by a CIA operator as blocks to construct a customized implant that will behave differently, for example maintaining persistence on the computer differently, depending on what particular features or capabilities are selected in the process of building the bundle. Additionally, Grasshopper provides a very flexible language to define rules that are used to perform a pre-installation survey of the target device, assuring that the payload will only be installed if the target has the right configuration. Through this grammar, CIA operators are able to build from very simple to very complex logic used to determine, for example, if the target device is running a specific version of Microsoft Windows, or if a particular antivirus product is running or not. Grasshopper allows tools to be installed using a variety of persistence mechanisms and modified using a variety of extensions, like encryption. The requirement list of the Automated Implant Branch, AIB, for Grasshopper puts special attention on PSP avoidance, so that any personal security products like MS Security Essentials, Rising, Symantec Endpoint or Kaspersky is on target machines do not detect Grasshopper elements. One of the persistence mechanisms used by the CIA here is stolen goods, whose components were taken from malware known as Carburp, a suspected Russian organized crime rootkit. Confirming the recycling of malware found on the Internet by the CIA. The source of Carburp was published online, and has allowed /RDB to easily steal components as needed from the malware. While the CIA claims that most of Carburp was not used in stolen goods, they do acknowledge that the persistence method and parts of the installer were taken and modified to fit our needs, providing a further example of reuse of portions of publicly available malware by the CIA, as observed in their analysis of leaked material from the Italian company hacking team. The documents WikiLeaks publishes today provide an insights into the process of building modern espionage tools and insights into how the CIA maintains persistence over infected Microsoft Windows computers, providing directions for those seeking to defend their systems to identify any existing compromise. Stolen Goods User Guide Scope. This document is the user manual for Stolen Goods v2.1, a persistence method for the Grasshopper installer or the shell-term shellcode injector. It provides a description of how stolen goods works, the payloads stolen goods can persist, and how to use stolen goods with Grasshopper and shell-term. S//NF, Stolen Goods 2.0 is fundamentally different from Stolen Goods 1.0. This user guide will not include information about Stolen Goods 1.0. Please see the original Stolen Goods 1.0 user guide for all 1.0 information. All information contained here is in reference to Stolen Goods 2.0 only. S//NF, Stolen Goods 2.1 adds a few core features, and other quality of life improvements. SG 2.1 adds support for Windows 8.1, x86 and x64, a limited stealth mechanism, and a network capture capability for use with IcePick 1.2. Stolen Goods 2.1, SG2, is a persistence module for Grasshopper and shell-term. Based on components from third-party malware. The components were taken from malware known as Carburp, a suspected Russian rootkit used by organized crime. The source of Carburp was published online, and has allowed /RDB to easily borrow components as needed from the malware. Most of Carburp was not used in Stolen Goods 2. Specifically all the botnet communications components, the persistence method, and Parts of the installer were taken and modified to fit our needs. All components taken from CarBurp were carefully analyzed for hidden functionality, backdoors, vulnerabilities, etc. A vast majority of the original CarBurp code that was used has been heavily modified. Very few pieces of the original code exist unmodified. S//NF SG2 maintains persistence by installing Custom Initial Program Loader, IPL. Code found in the Volume Boot Record, VBR, also known as the Partition Boot Record, or PBR. Using a series of function hooks, SG2 is able to maintain execution along the Windows boot sequence, when at one point it loads a stub driver into the system to maintain code execution after the boot process is finished. The stub driver borrows some ideas and components from the original CarBurp source, but most of the stub driver has been rewritten by RDB. S//NF SG2 is able to persist two different payloads at once, a DLL payload, GH1 or persistence spec compliant, and a driver payload, Jedi Mind Tricks, Ancient Protector. Specifically, the driver payload does not // need to be signed at all, even on 64-bit Windows systems.